we have learned about stack data structures. Now, let us see how a stack structures can be programmed using Java. So, in today's video lectures, we will see exactly how a stack can be realized, or a stack can be programming for a stack can be done using the concept of array. So, here basically we have to define different operations related to array, but all those operations in the view of that array is maintained using an array. The same thing again we can do, but using a linked list. And finally, I will demonstrate one application of a stack. This application is basically how an arithmetic expression can be evaluated. Now, regarding this array implementation, for example, say you want to stack implementation, say suppose you want to implement a stack using linked list, you do not have to define all linked list related operations and its definition. Whatever the linked list programs that we have done while we are discussing about programming for linked list, all the codes that those are created there, you can import into your program here while we are programming using stack. I will discuss these things. Let us proceed. First, let us see how a stack can be programmed using an array. Now, here is the basic definition that you can consider. So, first we have to declare that stack is an object. So, to declare these things, we can define a class. The name of the class is stack A, it means that stack using array, and we want to make the stack is a generic, that means this stack can store any type of data, integer, long, float, string, or any abstract data type. So, that is why we declare this class as a generic class. Okay, so, once we declare this class as a generic, then we have to include the field and the different methods in it. The first field that we have to declare that length, it will store what is the current length of the stack, and top is a pointer, it indicates that what is the top pointer of the stack, because a stack is characterized with a top pointer. So, top will basically says that index. So, basically it index varies from -1 to length -1. -1 indicates that stack is empty, and top equals to 0 indicate that just only one item there in the stack. So, in that case length is 1, and that is why length field is length -1 is the maximum. So, if the stack of size n, so length is equals to n actually, but the index varies from 0 to n -1, that you know. And here a stack essentially is a number of elements to be stored here. So, we declare is an array, the name of the array is data here. So, that is why this is the stack A declaration using array. So, this array data will store the elements in it, and the type of the element that this store as we have declared is a generic. So, this is the concept, and so there is a constructor. This constructor for any generic class, you know, for every generic class you have to define a constructors. So, this is the only constructor that is there. So, in this case, in this constructor we can pass an array, okay, is a reference to an array objects. So, this array objects will be initialized to the data. So, if you can create a stack initially passing an array. So, initially array is there, that array can be also null, in that case it will be null, that means we do not have any elements in it, and length equals to a dot length. So, a is, if it is null, then a dot length is 0, so it is 0, and top equals to -1. Initially the array has the pointer, top pointer is -1 because it is empty, stack is empty. So, this basically declares the basic thing, basic elements of the array, few fields and the container which basically contains the element into the stack. And then our next task is to add the different methods which is required to manipulate stack. It is just like a linked list programming that we have known. We have to create the linked list structure like, and then we have to add the methods those are required to manipulate linked list, like here the methods namely push, pop, whether array is empty or not is empty method, print stack, printing the all elements which are present in the stack, and like. So, now our task is to add all these methods one by one. So, let us discuss about how we can add the methods, and then our stack data structures can be defined and then finally it can be used. So, now we will add the first method, namely it is the push method. So, here is the method push, as know the push method require the element to be pushed. So, A is basically of type T. If T is integer, then A is of integer, T if is double, then A is of type double, T is string, then A is string, like. So, whatever it is there. So, this push method, and now this operation you see it is very. Now, push operation first check whether the stack is already full or not. So, here if top less than length minus 1, that means stack is not full, then we can go here. So, if not there, then top will be incremented by 1, and then at the location of the top the value A which passed here will be assigned. So, this way the element will be pushed into the stack, and then top pointer will be incremented by 1. So, top pointer is incremented by 1 here, as you see. If top is either equals to length minus 1 or greater than whatever it is there, then it will not push any item. In that case, we can say the stack overflow, that means stack is full. So, this is the method called the push method we can add into the stack structure that we are defining, class we are defining. Now, likewise we can add one more method. This is related to pop. Pop operation means it is just deleting the top element from the stack. Now, that method it is like this, again like push method we have to add one more method, and this is the body of the method. Now, this pop method does not require any argument to pass. So, that is why argument is void here, and this method you can see in case of push it does not return anything, but here it return the elements which is basically moved from the stack. So, T is basically the type that it will return. So, in that case the data type that the stack is used for, it will return of that type. So, initially T A equals to null. So, this value that needs to be returned is basically null at the moment. Then it check if the array is empty, stack is empty or not. So, if top equals to minus 1, it indicates that array is stack is empty. So, stack is underflow. So, you will not do anything. If it is not empty, then A, the value will be copied, the topmost value will be copied into the array A, and top will be decremented, because it is a case that okay, it is decremented and top go down once, and then it return A. So, this way this method will work for you, and this is the pop operation related to the stack structure. Now, next method it is empty, it check that whether it is empty or not. It is very simple method actually, just we have already know that how to check it. So, whether a stack is empty, that means T top equals to minus 1, it return true, else return false. So, this will not delete or not add anything, only check whether stack is empty or not. In many operations it is required to check whether stack is empty or not before applying stack operations there, that is why there. Now, so we have these are the essential operations related to the stack structure. Our next operations is basically print stack, it basically printing the entire stack. It is very simple, just it is the method that it print the whole array, because stack is now is an array here. So, this method is declared here, print stack method. This is the body, as this method does not return anything. So, it is a void. Now, here you see, first we will check that whether stack is empty. If stack is empty, then no more to print anything, that is why, else it will just a loop. In this loop, it will traverse each elements in the array starting from top to whatever it is there, I mean 0. So, here and it is there. So, this way it will print all the elements starting from the top to the bottom elements, it is there, and that is all. So, this is the print stack method, and this completes adding all the method push, pop, is empty and print stack, and your stack A is ready. Now, to test your program, again it is advisable that you should run a master program, a driver program calling all the methods that you have defined, starting with an empty array or adding some array into there. So, this is the driver method that I have given you for your practice. You can check this program. Here you see we declare A is an array of size 2 here, and here we create using this array A one stack. The name of the stack object is st. Now, here st dot push 5, we can insert one element here, then printing stack, then here. Now, you can understand what will happen is basically it will not be able to push it because size of the is 2 only. So, this will basically is a failed operation in this case, that you can check, and then otherwise you can see all these operations are valid, and finally, this also is empty for the stack, it check that whether stack is empty. Anyway, so you can just instead of 2 you can 10 and everything, you can go on adding and more data into and pushing more data into the stack, and pop operations again in between push, pop, whatever it is there, and you can check that this basically programs works for you. So, stack implementation or programming a stack using array is very simple actually. Now, we will discuss about the same thing, but using linked list. Now, stack implementation of stack or programming of stack using linked list, again very simple. What actually you have to do is that push operations, if you see, as we said, the stack is basically last in first out operation. That means you can understand that for the linked list, insertion and deletion related to the push and pop operation only. So, here push is basically insert at, in that case it is basically front, and then removal, I mean pop is also front, like whatever it is. Now, let us see how we can define these operations like. First of all, we have to import this basically is a directory where all the programs related to linked list, that basically that includes the linked list class declaration, JLL declaration that we have already done, J linked list, actually it is the name of the class that we have done, and all the methods that is there. So, we have to import that class actually here. Then we can define our stack objects using linked lists. Let the name of the stack class for this type of object is stack L, and we want to make it generic. So, that is why we are to define a generic class. So, stack L is a generic class with one only generic argument. Now, here this J linked list T, as you see, this is the one class we have already defined, which is there in this directory, and so we create a top is basically is a pointer, and this pointer is a type node because it is a node. So, this top is basically is a node to a linked list. So, we can say it is a header. and t is an integer variable. Just to note the length of the list, we can say L. So, this is the size of the stack we can say, and here is the constructor. So, that means initially it will define a stack, and here you see we created linked list. Actually, these are top is basically points to the linked list, that means is basically top is nothing but the header. So, top is header, and whenever the linked list constructor, if you can recall, it basically create a empty list with header points to a null, or link field of the header is basically null, or header, if it is header dot link is equals to null, we can say. So, is basically top actually. So, top is basically always points the first node of the linked list, that means it is the node which basically points the header node actually. So, this is the top, and t equals to 0, this indicates that initially the size of the stack is 0 because there is no elements in it. So, that is all. So, this basically completes the declaration of a linked list and its inclusion into a stack, maintaining a stack actually using linked list. Now, our next step is basically to add different methods related to this kind of stack manipulation, namely push, pop, isempty, print stack. Now, we have already exercised all these methods, but using array representation. Now, push, pop and isempty, print stack method is for the linked list implementation. Now, here, so as I told you, the idea is that push is basically insert front, pop is basically delete front, and isempty and print stack is basically traversal, and isempty is basically check that whether top points to a null or not, that is all. Now, let us see how all these methods, very simple method actually, how we can define all these method one by one. Now, here the push method, and the push and this data that we want to add into the stack. So, initially it will basically it will increment the size of the stack, because once you perform a push operation then it is 1, and then we just simply, you see what we are doing is that this basically the stack, top means its top, and at the top we have to insert front. So, we just simply add the insert a new node at the front of this of the linked list, single linked list we can say. In this case we are considering linked list, you can use again double linked list to maintain the stack also, no issue. So, this is the idea about push operation, and one more point that you can note is that in this case we do not have to check whether it is overflow or not or full or not, because the stack implementation using linked list theoretically having the unlimited size, because it will grow dynamically, unlike the array implementation where the size or length of the stack is limited to the size of the array. So, this is obviously one advantage why you can think for implementing a stack using linked list. Now, this is the push operation. Now, let us come to the pop operation. The pop operation is again like this one, but for the pop operation we have to check that whether list is empty or not. In case of list is empty, so pop there will be, pop operation is not possible, that is it is called stack is underflow. Now, here is the method for the pop operation, and it does not require any argument to pass, but it will return the value that it has popped successfully, and initially this data that it will return is null. Now, we can check if is not empty. Is empty is a method that we can discuss for this linked list again, and if it is not empty, then t is decremented by 1, because once the pop is successful, it basically reduce the size of the stack by 1, and here delete front operation, that means it will delete the frontmost node from the list which basically pointed by the top. So, this basically removing. Now, here if fails, that means if list is empty, then it will print that stack underflow, no more pop operation successful, and if is successful then it will return data. So, this is the pop operation. Now, next operation is basically is empty. It is pretty simple. It will basically check that if top is empty, return true or false. So, that means here for this is empty method is defined for the linked list. If you do not define it, you can write that if this dot top is equals to null, then return true or false. That is also you can do. I am assuming that is empty method is defined for the linked list. If it is not there, you can do it whatever it is there. So, we can actually what we are doing, you can check it, we are using all the methods those have been implemented for linked list to implement the method for the stack. That is what actually. So, that is why. So, we use the isEmpty method which is defined for the linked list to define the isEmpty method for the stack. So, that is the idea. Otherwise, you can just simply if top is equals to null, then you can say the return true else false. So, this also a valid operation that you can think about it. And our next operation for this, I mean programming of stack using linked list is basically print stack method. It is just like a traversal one, that means printing the whole linked list actually, or just we can go on whatever. Now, let us see what is the idea about it. If this is not empty, then obviously print list come into play. So, that is why you have to check that whether the list is empty or not. So, if it is empty, then it will print a message that it is empty, otherwise it will call the print list method. You can recall print list method once we have defined for the linked list structure. So, we call this method to print the entire list here, and then it basically defines the print stack method. So, all the method push, pop, isEmpty and print stack are defined. Now, this completes the declaration of the stack class, namely stack L using linked list. Now, once the program is over, I mean stack class is defined completely, we can again test the implementation by writing a master program. So, here is an example of a master program that I have declared here. Now, here you can see this is we are declaring a stack st, and then this is basically using linked list. So, stack L, and here the stack is to store the integer type. So, that is why, and these are the few method push, pop, all this driver method that we have discussed on for testing, like you have discussed also there, and this includes the this basically you can call the different methods in different orders and then you can test it. So, this basically completes the declaration of stack and testing this using both array as well as linked list. Now, our next important discussion will be application of stack. Now, while we are discussing about stack, that time we have mentioned that there are many applications on stack is possible, but we will not be able to discuss all applications, rather we will limit to only one application. This application is basically related to evaluation of arithmetic expression. Arithmetic expression evaluation, actually there are two steps, twofold method. The first is we have to convert an input expression into a postfix notation. So, input expression usually it is in infix notation. So, converting an infix notation into a postfix notation. Now, there is an algorithm for this conversion. For this algorithm, we have to take the confidence of precedence and associativity of all the orders, and I have also defined an algorithm that basically infix to postfix operation is basically depending on the elements to be pushed or popped from a stack or to a stack depending on their priority of the precedence, like this one. So, those algorithm you can follow. So, here actually implementation of the algorithm or writing a program so far infix to postfix notation is basically maintain a stack and then scan each element into the expression, namely infix expression, and then check whether we have to push or pop. Whatever it is pop and everything, this basically resulting to the ultimate output operation. Now, I have defined one program, I have already written one program for you, but discussing the entire program on step by step, it is very tedious job. So, I should suggest you to check the program. Once you can write the program and then run it and check it, every block of codes you can check it actually, so that you can understand. And while you are checking the code, only through going through the code cannot be, I mean it is not good to understand the program. So, side by side you can follow the algorithm for this method, that means infix to postfix, that we have discussed in the previous discussion. Now, what you have to do, I am giving an idea about that how we can apply it. Now, we will assume that in this program linked list implementation is for stack. So, whatever the method those are there for linked list implementation, that you have to import here, and then first you have to maintain a stack for this purpose. So, this is the stack that we have here. So, this is the stack, we have to make the stack ready for this program, and then we can discuss about the method. Now, this method has few block of code. The first actually for every what is called the symbol in your expression, you have to just return its precedence or priority value. Now, we will assume that symbol that is there in an expression is either a character or operator, that means plus, minus and everything, and here this basically all this priority or precedence of all these values is there. Here for others is basically this one, either means starting brackets or ending brackets is basically there. So, those are basically a single character as an operand, and these are the operator. We can assume that our expression includes this one only, then fine, then we just okay. So, this block here, this block, or we can say this is one function we can say, which basically starting a symbol, it will return what is its priority value, that is all. Okay. So, this is the first what is called a block, that is towards the infix to postfix conversion it is required, and the next part is basically implementation of the algorithm. That means, when you just read a symbol and then depending on its precedence compared to in stack one symbol, whether it needs to be pushed or pop, and accordingly we have to just call it, it is like this here. So, here this is the method that we are going to discuss about infix to postfix expression evaluation, and this basically results. So, I told you while we are processing this, it basically output towards the postfix notation actually there. Now, initially we will assume that our expression is stored in the form of a stack, and then it will contains the list actually. So, this basically stack is basically an linked list implementation, and here and then you see for loop will continue. We have other parts in the next slides also. So, expression dot length, expression is basically here, the expression means our input expression in infix notation rather. So, we have to continue starting from the first what is called the symbol in the expression, and then we have to take the character value, because this is a character symbol that we have to take it, and then is letter to digit. So, if it is a character symbol, we have to convert into the digit form like this one. So, whatever it is there. Now, here if you see, if the starting bracket in your input expression, it is the push, this is as per the algorithm. If you can follow, then you will be follow that okay, once you scan each elements into it, and then what to do, either push or pop, and the storing into the result into this array. So, this is the part of the program, it is continue, and the different situation is basically will be implemented using if and else statement, like if C is this one and stack is not empty, then you will pick it is there. Pick is basically one method is that it will check only topmost element, but will not remove it actually. That pick method you can write, you have not defined it, but you can easily do that. Then in that case the stack the element to be popped, and this one, and if it does not follow according to the correct valid expression, then it will check it also whatever. So, this basically complete implementation of the program related to algorithm related to infix to confix, it is there. So, if you follow the algorithm there and implement it, it is enough to understand this program. Now, once this method is there, we can test this method by writing a driver program, and then you can pass as any input valid infix expression or even invalid also, no problem. This algorithm, this program will take care, it basically convert into a postfix notation. So, this is the one program, it is there, and so this completes the program. And here you see the driver program, master program, expression is given like this, and it basically print the result. Expression is basically result, it is there and it will print. So, you can see how the program that basically infix to postfix conversion takes place. Now, so I just advise you to check the program, write the code in your machine, and then you can run it. Our next part, once the postfix form of the expression is available, we will be able to apply this program to evaluate an expression. So, now our next part is basically evaluating the postfix expression, and this is the program for the purpose. Here we can see this is the program, and this program basically define a method, and this again body as per the algorithm that we have already discussed earlier. So, that is okay, I do not want to discuss it, it is basically depending on the algorithm, either push and pop operation it is there. So, this will basically do it, and then finally the main method we can call it, this is the main method. In this main method, if you see expression will be given, here we will assume that all the expression will be expressed in terms of single digit operand, that is 2, 3, 1 star, like this one, and then this expression is in a postfix notation, and then you can call it. Otherwise, one thing is that you can just call, in this case you can give any input expression in this method and then call infix to postfix expression here and then carry on. So, it will basically starting from an infix notation of an expression, and finally it is evaluating, that also you can do it. So, you can just simply do many experiments with this program, you can modify, and then according to your understanding you can change the code, and then you can test it, and that is obviously useful to run the program much better. So, okay, fine, this we have discussed one application, there may be many more applications, you can find the book which I have referred here, and all the programs which I have followed in this lecture slide also you can find from this link. Okay, thank you very much.